Trans-European Transport Network, TEN-T. The TEN-T networks comprise two levels: the core network, to be completed by 2030, and the comprehensive network to be completed by 2050. The goal of the TEN-T network is a safe and sustainable EU transport system that promotes the seamless movement of goods and people. The TEN-T core network focuses on the most important connections and hubs. The implementation of the core network is advanced by a corridor-based approach. The TEN-T network covers all forms of transport: road, air, internal waterways, sea, as well as platforms enabling a combination of different forms of transport. The purpose of the Trans-European Transport Network, TEN-T Core Rail Network, is to create a cohesive, efficient, and high-quality transport infrastructure across Europe, primarily focused on rail, but also encompassing other modes like roads, inland waterways, and maritime routes. Its main goal is to foster economic growth, enhance social and territorial cohesion, reduce the environmental impact of transport, and improve safety and resilience within the network. Its objectives include 1. To elevate the safety, sustainability, speed, and convenience of the EU's transport network. It encourages a shift towards trains for passenger travel and promotes the use of rail, inland waterways, and short sea shipping for freight transport. 2. Infrastructure improvements. The regulation measures to address missing links and modernize the network. Notably, it sets quality standards such as enabling major TEN-T passenger rail lines to support speeds of 160 km per hour or faster by 2040, ensuring good navigation conditions for canals and rivers, enhancing transshipment terminals, and enabling piggyback services on the TEN-T rail network. 3. Urban mobility. Major cities are encouraged to formulate sustainable urban action plans, focusing on zero-emission mobility to support the transition towards more sustainable urban transport systems. Extended Core Network. The regulation introduces an extended core network, slated for completion by 2040. This addition aims to supplement the existing core and comprehensive networks. 5. European Transport Corridors. The regulation envisions merging the core network corridors with the rail freight corridors to form European Transport Corridors, fostering a more integrated and efficient transport network across Europe. The TEN-T core network plays a critical role in transforming transportation in Europe. This extensive network is designed to create a seamless and efficient transport system across the European Union, connecting major cities, ports, and logistical hubs through roads, railways, waterways, and airports. By removing bottlenecks and enhancing connectivity, the TEN-T core network is about improving transport and driving economic growth and sustainability. However, how does this European initiative relate to the challenges of EV infrastructure in the United States? Interestingly, the principles underlying the TEN-T core network can serve as a valuable blueprint for enhancing the U.S. EV infrastructure, particularly in deploying Type 2 charging stations. By understanding how Europe is integrating EV infrastructure into its transport network, the U.S. can adopt similar strategies to accelerate the adoption of electric vehicles, EVs, and reduce the carbon footprint of its transportation sector. Understanding the TEN-T core network. What is the TEN-T core network? The TEN-T core network is a vital part of the European Union's strategy to create a well-connected, efficient, and sustainable transportation infrastructure. This network includes the most crucial connections between major European cities, ports, and logistics centers. It is designed to remove barriers to seamless transportation, ensuring that goods and people can move efficiently across borders, reducing travel time, and enhancing economic cohesion within the EU. One of the main goals of the TEN-T core network is to integrate different modes of transport, road, rail, air, and waterways, into a single, cohesive network. This integration is vital for enhancing the flow of goods and passengers, boosting economic productivity, and reducing environmental impacts. The network is also designed to address the unique challenges posed by cross-border transportation, which is crucial for the smooth functioning of the single market. Crucial components of the TEN-T network. The TEN-T core network is structured around several key components. 1. Transport corridors. These are the main routes that connect major urban and industrial areas across Europe. The corridors are designed to handle high traffic volumes and are crucial for long-distance transportation of goods and passengers. 2 urban nodes. These are cities or regions where different transport modes intersect. Urban nodes play a crucial role in ensuring that passengers and goods can easily switch between different types of transport, such as from a train to a bus or from a ship to a truck. 3. Multimodal integration. One of the standout features of the TEN-T core network is its emphasis on integrating various modes of transport. The network minimizes bottlenecks and improves overall efficiency by ensuring that road, rail, air, and water transport are interconnected. TEN-T's role in EV infrastructure development. In recent years, the TEN-T core network has been at the forefront of integrating EV infrastructure across Europe. One critical area of focus is the deployment of Type 2 charging stations along the major transport corridors. The goal is to make long-distance EV travel feasible by ensuring charging stations are available every 60 kilometers along the network. This initiative aligns with the EU's broader commitment to reducing greenhouse gas emissions and promoting sustainable transportation. Integrating Type 2 charging stations within the TEN-T core network also supports the shift towards electric heavy-duty vehicles, HDVs, which are essential for reducing emissions in the logistics sector. By 2025, the network aims to have a comprehensive charging infrastructure that can support passenger EVs and HDVs, making electric transport a viable option for long-haul journeys. The EV infrastructure challenge in the USA. Current state of EV infrastructure in the US. The push towards electric vehicles has gained significant momentum in the United States, but the current EV infrastructure still faces several challenges. While the country has seen a steady increase in Type 2 charging stations, these are often concentrated in urban areas, leaving many highways and rural regions underserved. Moreover, the US needs a unified strategy for developing EV infrastructure, leading to inconsistent charging station availability across different states. This inconsistency poses a significant barrier to the widespread adoption of EVs, particularly for long-distance travel, where drivers may need help finding charging stations. Key challenges in expanding EV infrastructure. Expanding the EV infrastructure in the US involves addressing several key challenges. 1. Inconsistent charging station distribution. While major cities may have adequate charging infrastructure, many rural areas and highways still lack it. This uneven distribution makes it difficult for EV owners to travel long distances without worrying about running out of charge. 2. Varying state policies. Different states have different policies regarding EV infrastructure, which can create confusion and hinder the development of a cohesive national network of Type 2 charging stations. 3. Long-distance travel limitations. The need for charging infrastructure along highways and in remote areas is a significant challenge for long-distance EV travel. Without reliable access to Type 2 charging stations, drivers are less likely to choose EVs for long road trips. Lessons from the TEN-T core network for the U.S. strategic infrastructure. Planning. One key lesson the U.S. can take away from the TEN-T core network is the significance of strategic infrastructure planning. The network's deliberate placement of Type 2 charging stations along major transport corridors has demonstrated the feasibility of establishing a supportive network for long-distance EV travel and promoting the widespread use of electric vehicles. The U.S. would implement a comparable strategy by pinpointing critical transport routes that need to be expanded EV infrastructure and ensuring the availability of Type 2 charging stations at regular intervals along these routes. Integrating EV infrastructure with existing transport networks. Another crucial lesson from the TEN-T core network is the need for integration. The U.S. can create a more cohesive and efficient EV infrastructure by ensuring that Type 2 charging stations are integrated with existing transport networks. This could involve placing charging stations at major transport hubs, such as airports, train stations, and bus depots, to make it easier for travelers to switch between different modes of transport.
Public-private partnerships and funding. Funding is crucial for expanding EV infrastructure, and the TEN-T core network provides valuable insights into how public-private partnerships can finance the deployment of Type 2 charging stations. In the U.S., partnerships between government agencies, private companies, and local communities could provide the necessary funding and expertise to accelerate the development of a robust EV infrastructure. Practical applications of 10T strategies in U.S. cities. Case studies of U.S. cities implementing 10T-inspired solutions. Several U.S. cities have already implemented 10T core network-inspired solutions to enhance their EV infrastructure. For example, cities like Los Angeles and New York have started integrating Type 2 charging stations into their public transportation systems. They are working towards creating a more connected and sustainable urban transport network. Steps for local governments to support EV adoption. 1. Develop EV-friendly policies. Create and implement policies that encourage the installation of Type 2 charging stations in public and private spaces. 2. Provide business incentives. To promote widespread adoption, offer incentives to businesses that invest in EV infrastructure, such as tax breaks or grants. 3. Ensure accessibility. To support equitable EV adoption, charging stations must be easily accessible to all residents, including in underserved areas. The long-term benefits of a robust EV infrastructure. The 10T core network provides a powerful example of how strategic infrastructure planning can drive the adoption of electric vehicles and promote sustainable transportation. By applying the principles of the 10T core network to the U.S. context, we can overcome the current challenges in EV infrastructure and create a network that supports the widespread adoption of electric vehicles. For U.S. cities and states, adopting a cohesive and well-planned approach to EV infrastructure will benefit the environment and contribute to long-term economic growth by making transportation more efficient and sustainable.